channel. So in this video, there are two goals. The first goal, of course, is to solve this problem and do some live coding here. And the second goal is to see how you should behave in a real coding interview. So before we start the real content for today, I would really appreciate that if you can help subscribe this channel because it can help me to grow. So thanks a lot. So let's get started. First of all, in the real coding interview, you need to understand the question. Remember, don't jump into the coding part too quickly. Try to have a nice discussion, understanding the question, and if there's anything unclear, please clarify the question with the interviewer, and also at the same time think about some edge cases. Let's resolve this problem. It's called next greater element 2. So given a circular array, the next element of the last element is the first element of the array. So print the next greater number for every element. So the next greater number of a number x is the first greater number to its traversal order next in the array, which means you could search circular to find its next greater number. If it doesn't exist, output -1 for this number. So this is very similar to another question which is called next greater element 1. So in that question we used a stack to solve this problem, and here it is also okay to use a stack to solve this problem. So the next part we are going to find how to solve this problem. So in a real coding interview, you need to discuss with the interviewer how you're going to solve this problem. Please get an agreement on the solution before start coding. So for this one, we are going to use stack to solve this problem. We are actually going through the input array twice, like from the beginning to the end, then from the beginning to the end, because this one is asking us to find the next greater number, which could be circular. So if we like have a copy of the array and append to the end, something like that, then for sure we are going to be able to find the next greater number for the last number. So having said that, the runtime is going to be O of n. N is the length of the array. Let me introduce how we are going to use stack to solve this problem. So we are going to have a stack. So every time, let's use this example. Let's say 1 to 1 to 1. So if the stack is empty, or if the stack, if the top element of the stack is larger than the current number, then we are going to push the number into the stack. So first, for the first one, we are going to push 1 into the stack, and then when we encounter another number which is greater than the top element within this array, then we are going to dump that. We are going to pop that out, and then add this into the final result. So in the stack, actually, instead of pushing the real number into the stack, we need to push the index into the stack, so that we can update the final result array. So let's say we have the result array. At the very beginning, we push 1 into it, and 1, actually this is 0 because it is indexed. And we see that the next number has index 1, which is 2. So 2 is larger than 1, so we are going to update that, this one as 2. And then we are going to push 1 into it. And then we see a 1 here. So 1 is a smaller thing, so we are going to have the stack to be pushed into here. And then we have another. Then we go through this again from the beginning to the end. So we see that 1 is still it is equal. So it's not like we don't need to do that. We cannot really push. We cannot really update the result array. So instead, what we are going to do is we are going to push this into the array. And then we see that, okay, the next number, which is 2 is larger than the 1, though, so we are going to pop that out and update the result array. This one is 2. And then we see that this 2 is larger than the third number, which is in the stack, so we are going to have this update as 2 as well. So after that, we are going to push another 1 into here, and then another 2 into here, and finally we see that only this one is not updated. So if the place is not updated, then we are going to have this as -1. So let's see if this is something. So it says that the greater number, if it doesn't exit output as -1 for this. So I don't see the range of the input array, so I think at the same time we need to keep record of the places we have updated using a set. So the set is contains all the integers. So each integer is the index of the array. So this one it keep record of the index that has been updated in result. So I would say that's pretty much it. And at the end, because this position it is not in the set, so we are going to set it as -1. So the reason we keep this set is because we don't know whether the input array is all positive number. If it's all positive number, then of course we can initialize everything as -1. But actually, what we could do, we could make it simpler. So we don't need to use a stack here. Instead, what we could do, we can initialize everything within the result array into as -1, and then we just update it regularly. So if the position is not updated, then it is -1. So we don't need to keep the set. Okay, so that one could make things simpler. So the runtime is still all of n, and space-wise it could be all of n as well. So having said that, let's do some coding work. So for coding, please care about the correctness of the code, readability of the code, and also don't be too slow. So first of all, of course, so it doesn't have any constraints. So the one edge case I could think of is a empty thing. So if it is empty, what should we return? So if it is empty, let's say we just return a num pointer. Then let's say we just return a num pointer. Otherwise, it is our general algorithm. So we are going to have int nums, and we initialize everything as -1. And then we have the stack here. So remember, in the stack it is the index of the number within the array instead of the value. So we are going to go through the array twice. So as 0 I smaller than nums dot length times 2 -1. So this is actually, if it is times 2, okay, so it is nums dot length times 2, okay, plus I. So this means we are going to go through the array twice. So int idx is equal to I modular nums dot length. If the stack dot empty is empty, if the stack is empty, or the stack dot peak, if the top element of the stack is larger than the current number, so this is nums idx, then we are going to push. Then we are going to do the push into the stacks dot push. It is actually nums because it's indexed, so it is we should have this nums here. So you're going to push the index here, and then we're just going to continue. Otherwise, we are going to say, well, the stack dot well, the stack is not empty, and the nums stack dot peak is smaller than nums index. Then we are going to keep popping things. So int is equal to stack dot peak pop. So this is actually the index of it. So we are going to update. We are going to have update next item as equal to nums idx. Okay, and finally we are going to have stack dot push idx. And finally we're going to return the result. So this is pretty much the implementation. So remember, after you're done with coding, please do some testing as well. So let's rely on this platform to help us to do the debugging work. And also let's do a submission. Okay, it's the wrong answer. Okay, so when it is 0, then we are going to return none. Okay. So it's not none, but instead we return an empty array. So here I think this one should help us fix the edge case here. Alright, so let's do another submission. Oh, alright, so everything works well now. So this is pretty simple question. And that's it for the coding work. If you have any question regarding the solution or regarding the coding, whatever, feel free to leave some comments below. If you like this video, please help subscribe to this channel. I'll see you next time. Thanks for watching.